Good morning students, this is Junita Mukherjee once again in SS Public School giving you some important topics of this particular chapter and explaining you the chapter right now. So thermal properties of matter, this is the chapter we have, and in this particular chapter the next topic which we are going to start is about the heat transfer. How the heat is being transferred in the environment. These are the three different methods. First one is the conduction, second one is the convection, and third one is the radiation. So conduction is a process in which the heat is being transferred from one adjacent part of a body to the another part of the body itself. That is what we call the conduction. And we have here we have this thermal conductivity of the material. Constant of thermal proportionality constant is K, which is given by H is equals to KATC upon TP upon L, where we have the SI unit of K is joule per second per meter per Kelvin, or W per M per K. Thermal conductivity has various substances of the been listed below: metals, non-metals, and gases. Thermal conductivity has been explained. So convection is a kind of a transfer of the heat, or the transfer of the heat transfer, in which we are considering the heat land breeze and the sea breeze itself, which is defined by when the day is being hotter and the land is being more warmer in comparison to that of the sea. If we compare the land and the sea, we are getting the sea breeze in this particular manner. When in the daytime we are getting the sea breeze, that is land is particularly is more warmer in comparison to that of the sea. And in the case of night, we are considering the sea water is more warmer in comparison to the land, where we are getting the land breeze from this at the night time itself. So this is how the convection takes place. And the radiations of the from particular material, when are being allowed to fall on a particular substance, then from that particular radiations we are getting, or we can give an example of a sun. The radiations of the sun are falling to the earth, and thus the earth becomes warmer or hotter in the case of daytime in comparison to that of the night time itself. So this is how this radiation is being helped out. Now we will slowly move on to the transfer of the heat, that is first one, conduction. So first, this is conduction, and in this particular conduction, how it has been explained, let's see. Conduction is a mechanism of transfer of heat between two adjacent parts of a body because of their temperature difference. Suppose one end of a metallic rod is put in a flame, and the other end of the rod will soon be hot, so hot that you cannot hold it with your bare hands. Here heat transfer takes place by conduction from the hotter end of the rod to the different parts of the body. So when we are considering a rod, when it is being heated at taken at the top of the fire, and it is being heated up, the other hand will be much hotter to hold it properly, and that is what we call the conduction. And this can be helped, which can be used, or which can be taken an example of a spoon itself. If we make the spoon hotter, more hotter, so that we will not be able to hold it properly with our hands, with our bare hands. So that is the process of conduction itself. So gases are the poor thermal conductivity. Heat transfer from conduction of the hotter end to the rod itself is different parts of the another end. Gases are poor thermal conductors, while liquids have conductivity intermediate between solid and gas. Heat conduction may be described quantitatively at the time rate of heat flow in a material from a given temperature difference. Consider a metallic bar of length L and uniform cross section A with the two ends maintained at the different temperature. This can be done, for example, by putting the end of the thermal contact with large reservoirs at the temperature, say Tc and TD respectively. Let us assume that the ideal conduction, that the sides of the bars are fully insulated, so that no heat is exchanged between the sides and the surrounding. After some time, a steady heat is reached and the temperature of the bar decreases uniformly with the distance from Tc to Td, where Tc is greater than Td. The reservoir at C supplies heat at a constant temperature at a constant rate which transfer the bar and is given out by the same rate of the reservoir at D. It is being found experimentally that the steady rate, the rate of flow of heat of the heat current H is proportional to the heat difference, temperature difference Tc minus Td, and across the cross section area of the cross section A is inversely proportional to the length of the conductor itself. So here we have taken the heat transfer as just like this. We have taken containers like this. Okay, this is the container. Okay, this is what we have the rod here. Here we have the rod in which the heat is being flown. This is Tc and this is Td. We have here the reservoirs at C. So steady heat flows by conduction in the bar. So with the help of the bar, steady heat is flown from one point to the another point, and thus the two ends are maintained temperature between Tc and Td, and the Tc is greater than Td. We have Tc, this side is greater in comparison with that of the Td, that is temperature difference, and Tc minus Td will be there. Okay, and it will be inversely proportional to the length itself. So the constant of proportionality K is defined by this value. H is equals to Ka Tc minus Td upon L. So the constant of proportionality K is the thermal conductivity of the material. The greater the value of the K for the material, the more rapidly it will conduct heat. The SI unit of K is, as I told you, W per M watt per meter per Kelvin. The thermal conductivity of the various substances are listed in the table. These values are slightly with the temperature, but can be considered to be constant at the normal temperature range. Compare the relative large thermal conductivity of the good thermal conductors and metals with the relative small temperature conductivity of some good thermal insulators such as wood and glass wool. You may have noticed that some cooking pots have copper coating on the bottom, being a good conductor of heat. Copper promotes the distribution of the heat over the bottom of a pot for uniform cooking. Plastic foams, on the other hand, are good insulators mainly because they contain pockets of air. Recall these gases are poor conductors and not the low temperature conductivity of air in table 11.5. Heat retention and transfer are important in many other applications. Houses made of concrete roofs get very hot during summer days during thermal conductivity of concrete, so that through much smaller than that of the metal is still not small enough. Therefore, people usually prefer to give a layer of earth or foam insulators of the ceiling so that heat transfer is prohibited and keep the room cooler. In some situations, heat transfer is critical in a nuclear reactor. For example, elaboration heat transfer system needs to be installed so that the enormous heat produced by the nuclear fission in the core transmits out sufficiently fast than prevent the core from overheating. So these are the things which are being explained here in this particular topic of conduction. Moving forward for another topic in which I will explain you the convection process in detail. Thank you, students.